A sound arrives before the sky goes dark. It starts like wind, then becomes a roar, and then the sun in northern Kenya simply disappears behind a living cloud. This is a desert locust swarm, and in a single square kilometer, it can carry 80 million insects, each one eating its own body weight in green every day. Governments across East Africa spent hundreds of millions of dollars trying to kill these swarms with chemical poison sprayed from planes. And the thing that actually fought them best was not a chemical at all. It was alive, it was almost free, and it killed locusts from the inside out. Let me rewind to where this began. Between 2019 and 2021, the Horn of Africa was hit by the worst desert locust upsurge in living memory. For Kenya, it was the worst in roughly 70 years. Farmers in Turkana and Marsabit watched a green countryside turn brown in hours. A swarm would land, strip every leaf, every stalk, every blade, and then lift back into the air and fly to the next field. Whole harvests, gone before lunch. To understand the panic, you have to understand the math of a swarm. The Food and Agriculture Organization, the FAO, puts it plainly. 1 square kilometer of desert locusts can eat the same amount of food in one day as 35,000 people. Picture a small city sitting down to dinner inside one farmer's field and finishing every plant in sight. And these swarms were not small. The largest stretched for many kilometers across the Kenyan sky. This was not only a Kenyan emergency, either. The desert locust upsurge swept across more than 20 countries, from the Horn of Africa through the Arabian Peninsula and into Southwest Asia. In northern Kenya, the swarms grounded small plains and blanketed roads, and across the region, the FAO warned that tens of millions of people who were already short on food now faced a pest that ate their next harvest before it could be picked. Food security, that quiet phrase, suddenly meant whether a family in Marsabit would have anything to plant against. Now, hold that number, because here is the part that makes a locust outbreak almost impossible to outrun. These insects are not stuck in one place. A desert locust swarm can travel up to 1,050 kilometers in a single week, flying 9 to 10 hours a day, eating the whole way. So a country cannot simply wait for them to pass. By the time you see the swarm, it has already chosen tomorrow's field, 200 kilometers away. You are always behind. So how do you fight something that moves like weather and eats like a city? The default answer, for decades, has been chemicals. Pour money into pesticide, load it onto planes, and spray. And spray, Kenya did. The FAO ran an emergency appeal worth about $230 million, and across the region, control teams treated nearly 2.3 million hectares of infested land, most of it by spraying. This was a war fought with aircraft and chemical tanks, and it was extraordinarily expensive. And it was a war that never seemed to end, because every kill was temporary. A chemical breaks down in days. The locusts kept breeding faster than the planes could refuel. At one point, Kenyan officials publicly warned that the country was about to run out of pesticide entirely, with new swarms still hatching in the bush. So, picture the position the government was in. Burning through a national emergency budget, watching the poison stockpile shrink, watching the bees die, and still the sky kept filling up. The chemical answer was not just costly. It was a treadmill, and Kenya was losing ground on it. But here's the first turn in the story. The poison worked on locusts, and it also worked on almost everything else. Reporting from Kenya later revealed that the country procured nearly 200,000 liters of pesticide, and most of it was organophosphates, chemicals like phenotrophion and chlorpyrifos. Those are nerve agents for insects, and they are banned on food crops across most Western countries for their proven toxicity. They do not ask what they are landing on. In Samburu County, investigators found spraying at 34 liters per hectare, when the recommended rate was about 1 liter per hectare. That is more than 30 times too much. Beekeepers reported their honeybees dying in heaps after the planes passed. One farmer in the north, a man named Mohammed Adan, was poisoned so badly that he spent 3 years and multiple surgeries trying to recover. The chemicals that were supposed to save the harvest were quietly wrecking the land and the people they were meant to protect. And the bees were not the only casualties. In Marsabit, conservationists raised alarms that the pesticide drifting across the landscape was threatening rare bird species, the very wildlife that, in a healthier story, would have been eating the locusts for free. This is the hidden bill on the chemical invoice. You pay for the poison once, and then you pay again in dead pollinators, sick farmers, contaminated soil, and birds falling silent. The price tag on the canister never tells you the real cost. Hold on to that idea, because in a moment we are going to weigh it against a very different kind of price. So you have the trap laid out, locusts that move like a storm, a poison that costs a fortune and harms the bees, the soil, and the families living on it, and a clock that never stops because the swarm is always flying to the next valley. Surely there had to be a smarter weapon. There was, and it had been waiting in a laboratory for more than 20 years. Its name is Metarhizium agridum. From here on, I will just call it the fungus. It is a naturally occurring fungus that scientists discovered does something remarkable. Most of its relatives attack a wide range of insects, but this one is a specialist. It infects only locusts and grasshoppers. Bees can land on a treated plant and walk away unharmed. Birds, livestock, people, the other insects in the soil, all of them are left alone. The fungus reads its target like a lock reads a key, and locusts are the only thing it opens. Researchers turned this fungus into a product, and that took patience measured in decades. Through the 1990s, an international team running a project called Lubulosa hunted for the right strain, the one virulent enough to wipe out a swarm, but narrow enough to spare everything else. They registered it under two names you may have heard: green mussel and Novacrid. It is mixed into an oil and sprayed much like a chemical, with the same planes and the same ground crews, so no country has to reinvent its equipment to use it. But what happens after it lands is something a chemical can never do. Here is how the fungus kills, and it is genuinely strange. A locust walks across a sprayed leaf, or another locust brushes against it in the swarm, and microscopic fungal spores stick to its shell. Those spores germinate right there on the outside of the insect. Then they do something almost surgical. They release enzymes that dissolve a tiny hole in the locust's hard outer skeleton, and they drill inward. Once inside, the fungus stops being a passenger and becomes a parasite. It multiplies in the locust's blood, draining the insect's energy reserves, breaking down the very sugar that keeps it alive. The locust slows, stops feeding, and dies from the inside out. Then, the fungus pushes back through the body, releases a fresh cloud of spores, and waits for the next victim. That last detail is the quiet revolution. A chemical sprayed today is gone tomorrow. The fungus is alive, so under the right damp conditions, it can keep spreading from dead locusts to living ones, doing free work long after the planes have flown home. You are not buying one kill. You are seeding a self-spreading outbreak of locust-specific disease, paid for once. This is why people started calling it nature's own pesticide. But did it actually work in the field, against a real Kenyan swarm? That was the test, and the skeptics were loud. Chemicals act in hours. The fungus needs days, because biology takes time. To a farmer, watching his field vanish, days can feel like surrender. So, in 2020, during the height of the invasion, trials went out in Turkana and Marsabit, two of the hardest-hit counties in the north. The results were hard to argue with. In those trials, the fungus eliminated an estimated 90% of the locusts it was tested against. 90%, with a treatment that left the bees alive and the farmer unpoisoned. And this was not a fluke of one season. Years earlier, in large field trials in the Sahel, plots treated with green mussel had collapsed the grasshopper populations by more than 80% within weeks, while neighboring chemical plots still crawled with survivors. The fungus had been quietly proving itself for a generation. The FAO's own scientific advisory body looked at the evidence and called biological control the most appropriate option for fighting locusts, even while noting it carried a higher price on the invoice. And that word, price, is where this whole story turns on its head. Because the chemical war looked cheap on a single day and turned out to be ruinously expensive once you added up the dead bees, the poisoned soil, the sick farmers, and the planes flying mission after mission. The fungus looked pricey on the invoice, and turned out to be the bargain, because it does part of the job by itself, for nothing, by simply staying alive and spreading, a fraction of the true cost, paid mostly by nature. I want to be careful and honest with you here, because the title of this video says the fungus did it for free, and life is never quite that clean. Somebody still has to grow the fungus, bottle it, fly the plane, and pay the crew. It is not literally free. But compare what you are buying. With chemicals, every drop is spent the moment it lands, and a lot of that money also pays a hidden tax in poisoned land. With the fungus, you are buying something that keeps working after you stop paying, a living agent that hunts only locusts and hands you the next round of kills at no extra charge. Almost for nothing, in the way that mattered to a farmer in Turkana watching his last field. That is the closest thing to free that a war against 80 million insects per square kilometer is ever going to get. So why is the whole continent not switching tomorrow? Here is the honest, frustrating answer. Locusts come and go. They erupt, they devastate, and then they vanish for years. A factory cannot stay open making a product that customers only need once a decade, so production is fragile and supplies run thin exactly when the swarms return. The science is solved. The economics of being ready are not. That is the real fight now, and it is a fight about money and patience, not about whether the fungus works. There is a bigger picture worth holding here, too. When that 2020 crisis finally eased, the FAO estimated the control effort had saved around 4.5 million tons of crops and protected the food of more than 40 million people. That is the size of the stakes. Now imagine running that same rescue with a tool that spreads itself, that does not poison the people you are trying to feed, that turns each dead locust into the seed of the next kill. The scale is not theoretical. It is the difference between a region that survives the next plague intact and one that limps out of it poisoned. Think about what this means for the next outbreak, because there will be a next one. The desert is already warming, and the rains are already shifting, and the conditions that triggered this plague are not going away. The countries of East Africa now know they have a weapon that kills the locust and spares everything else. The question is whether anyone will pay to keep it on the shelf before the sky goes dark again. That is the difference between fighting the next swarm with poison and a panic, or fighting it with a living thing that finishes the job for almost nothing. If stories like this one change how you see the natural world, the quiet machinery underneath the headlines, then subscribe and stay with this channel. Because we go looking for exactly these turns, the moments where nature out-engineers us. Subscribe now so the next one finds you. And the next one is a big one. Kenya planted 50 million trees to stop the desert, and 40 years later, the map had changed. That story is coming next.